extending Marlin with custom G-code commands today in Mikey's lab. This video is sponsored by 3D Printing Canada. Hi, and welcome back to the lab. If you haven't already, hit that subscribe button down below. Make sure you stay up to date with all the content that we produce in the lab. Now, today we're looking at extending the capabilities of Marlin Firmware in a 3D printer by creating custom G-code commands. Now, where this came from? Quite simple. If you remember my buttery smooth time-lapse tutorial, I don't like the switch. So what I want to be able to do is have the slicer throw in a G-code command that toggles one of the free I/O pins on the control board of the printer, which then uses transistors or a microcontroller, if I want to do multiple transistors, to take the pictures from multiple cameras. That's the end target. But right now we're going to focus on how to create a custom command in G-code and where you do it and what you need to modify in Marlin. So what I have here is I have the Creality Melty board. I've tacked into the extra I/O called EXT-A2. I decided to do it with the default one to begin with, simply because I think most of you will be there. If you're like me and you have like an SKR 1.4, you're going to have free extra pins that are on headers already. I have an LED in place, and then I just have a ground connection to the in-circuit system programmer. So what I'm going to do is I'm going to open up my serial terminal. Alright, so here we have the standard output. When the Melty board boots, you can see this is Marlin 2.0.6. It has no SD card. Hard-coded default settings loaded because I had literally just burned this firmware. So we're going to go ahead and M6453. We're going to say that we're going to do pin 29. And we're going to turn it on for 1 second. So if I point this up at you so you have a better chance of seeing it, because there's a giant window right here. And I hit send, the LED turns on, and then off a second later. Let's make it a little more apparent. Let's go ahead and issue the same command, but say for 5 seconds. So, pretty straightforward. Let's dive down and take a look at how I did this. Alright. So here we are, we're at the PC. We're going to take a look at the source code changes that are necessary in Marlin in order to have a custom G-code command like you saw, the one on the desk. Mine's M6453, obviously. I picked a number well out of the range of what you'll find other commands in, just to make sure that it never conflicts. So the first thing, when you have a vanilla Marlin like this, which we just have the configuration for the Ender 3 added, we need to tell it that we're using the Sanguino. Alright, so if you come into here, right, you see the default EMS is being declared for the 2560. That's not the one that this processor that the Melty uses, so we need to go down and find the one that uses it. So we need to find the code for the processor that the Melty uses, which is the Sanguino, right, and it's the 1284p. So we'll go ahead and we'll just grab that string. And we'll come up here and we'll throw it into our default environment variables. Okay. And then after almost every change, I just like to hit compile. It's going to go through and it's going to build a bunch of objects. The first compile always takes longer because it builds pre-compiled objects that don't need to be recompiled in the next compile, since you didn't change any part of that. I like to get the first compile out of the way relatively early, that way I'm not waiting a long period of time in between changes to see if what I did broke something. So you can see it producing all of these .o files, which are object files, and they're partially compiled pieces of the source code for the CPP file that's being mentioned above. And if you don't modify that CPP file or the H file that's attributed to it, it doesn't have to recompile this part, and that's what makes it so much faster in the next compile run.
Alright, so on the basic configuration already, we've run out of memory on the Sanguino. This is something that is very common with Melty board. Marlin has gotten so big that it is dreadfully close to overflowing memory all the time. So we're just going to drop into configuration.h, and I'm going to get rid of some low-hanging targets here. And we're going to get rid of the boot screen images and the custom boot screen, and let's see if we can compile now. Unfortunately, when changing configuration.h, almost every file has something to do with the defines and the settings that are set in this file. So this is like the Achilles heel for recompiling. You're going to have to recompile a lot of pieces every time you change this one file. So the idea here is that I want to get through as many of the changes as I can in this one file and then just not touch it again so that the compiling is fast. Now we're back at the linking stage, and you can see now that we have enough memory and it definitely succeeded. Alright, so now we have kind of a base install for what we're going to be working with. There are a couple of places in the source code that we need to make changes to create a custom Gcode command. We need to go into the source folder, and we need to figure out where it hides the Gcode. So I guess, probably Gcode. Right? And the first one that we're going to do is we're going to come down here to gcode.h. If you're familiar with C++, which honestly, if you're working on this level of the modification to firmware, you probably should be at least passingly familiar. Header files and CPP files go together. So the header file is often like just definitions, whereas declarations, and the CPP file is usually definitions. So if we go into the Gcode file here, this contains a list of all the existing Gcode commands that are in here. Right, because again, I like documentation. I like to be able to tell what's going on later. And I'm adding the command simply so I can toggle an output or a pin on the microcontroller to take a time-lapse picture. If we scroll through here, you see very quickly that almost every Gcode command now has a function that is declared to go with it. So I'm just going to scroll all the way to the bottom here. So we're going to add the handler for our M6453 command into what it knows as its general list of Gcode commands. Right, and then we're going to go ahead and go over to the CPP file, which is the actual definition of what we're going to be doing with this. So we go over here, and we scroll down. This is the definition of all of the functions that existed before, and most of them are pretty straightforward, and they're done in a case statement. So the first case statement we want to find is the one that says M. So any command that starts with M, since we're adding an M6453, we want it to be inside of here. And we follow it down. This is a long list of commands, obviously. I always like to put my changes at the end. It makes it easier to find later. So we're just looking for the end if to I found the beginning lead of an M, which is here, and before the default. So I don't really care if we have an enabled thing, but if enabled enable custom Gcode. If we're here, and if it's a case 6453 being the command that follows the M section, right, then I want you to execute a function called M6453, and then I want you to break, because there's no point in continuing after, since this is a case statement. So this function doesn't exist yet, but we're about to make it. So what happens is when the parser comes through and it finds the first letter of a command is M, it comes into this giant case statement. Then it looks at the number that follows it to see what command it is. I'm again using 6453 to be way out of the range of any other thing that might be there. And we call a function called M6453. So now let's go define what M6453 is. And this is the last file that we really have to modify, and we actually have to create this one. So now that we're calling that M6453 command, I consider this to be a control command. So we're going to open up the control subfolder here. We're going to right click and we're going to go new file. And we're going to call this M6453.cpp. Now, there doesn't have to be a .h file associated with a .cpp, and all of these commands don't seem to have a .h associated with them, so I'm not going to create one in this case. So the first thing I'm going to do is grab the standard boilerplate license information that we find in every other one of these. The only difference is that I've said that I've written this file, because obviously I have. So the first thing that we need to include in this section, because it will be needed definitely by the actual Gcode command, is we need to include the Gcode header file. Now, this file contains an if not defined at the beginning, so it can only ever be included once. So you can call include all you want, and if something before you has already included it into the source of this program, it won't get included again. So it is generally best practice to include it everywhere you're going to need it, because it's not going to take any more memory. Now the next thing that we're definitely going to need, because we're dealing with in a pin protected mode, we're going to need to bring in Marlin core.h, which gives us a function that allows us to determine if a pin is currently being used for motion or is protected by another thing that is being used down the line. Marlin is a very both simplistic and complex, if that makes any sense, piece of software. So I can't possibly go through and explain everything that there is to know about how Marlin works, but because of the protected pins, if you try, what I want is if we try to toggle a pin that is already doing something that's critical, I don't want it to toggle. I want it to kick back and give you an error, right, and say, no, that pin we can't use. Okay, and then the last one that I include with all of these is Marlin config. Right, that can be useful for things like pin definitions. So, the next thing that you will find in most of these is a definition of the command itself and what parameters it takes. So I have one handy dandy already typed up here that I'm just going to copy and paste into here. So what we're doing, M6453 is going to be the command. It takes in a parameter I. If it's there, we say that we ignore pin protection. This should only ever be used in debugging because this is dangerous. Most of the time that I'm using this, I won't contain the I. P, followed by a number, is the pin number from the microcontroller that we want to trigger in order to take the picture. And S, followed by a number, is how long we want to hold that pin high. So let's go ahead and actually dive right in and and create the Gcode command, I'm going to copy and paste the commands here that you've already seen working, and then we'll talk about what they do. So we have the Gcode suite object that we are extending with the function M6453, which is what that select case in the previous, or switch case in the previous file was looking for. So what I'm doing here is I'm taking a look at the input from the command. I'm looking for the value P, and if I find it, I'm assigning it to pin index. If I'm not, the default is 29. Now I chose 29 because that is the EXTA2 pin on the Melty board, so I know it's free. And that way I don't have to define it every time I call M6453. It will automatically default to that. Okay, so I wanted to have some protection here. So if the pin index that we get back from the parsing that command is less than 0, we're just going to return, because obviously something is not right. So we change that pin index into an actual pin object inside of Marlin using the getPinMapPin command, and now we have a constant object that can't change and will always be that pin. So the next thing we do is let's take a look at what is present inside of the command, and this time we're looking for I, right, and whether or not the pin is protected. Okay, so if we haven't defined an I, which we didn't say ignore protected pin, and the pin that we're trying to use is protected, then we return the pin protected error, which will spit out an error in the console saying that you're trying to modify or work with a pin that is currently protected. You can't. This is a very good safety precaution. I would definitely recommend that people keep this one. The next one we're looking for is a value for S. So if we don't find a value for S, we're just going to return, right? Because you're telling me to toggle this pin for 0 milliseconds, and I did. So the constant int shutter weight, right? We parse out the S value, and the default is 500. So if we didn't specify a value for S, it should get the 500, right? So at the most, or in default settings, we're going to turn around and we're going to toggle this pin for half a second or 500 milliseconds. So we set the pin mode for the pin to output, right? We digital write the pin high. We dwell, which is a custom command in Marlin. It's kind of like delay. I hate them, but dwell allows Marlin to continue to do stuff in the background, so we're not stopping the main loop of execution, which is why I hate delay. And then we set the pin back to low. There is an improvement that we could do here. We could read the current pin state and make sure that we go back to the existing pin state. I don't think it's overly necessary in this particular situation, since we're going to always be using a pin that's not doing anything else. So at this point, we actually are done editing the firmware. So now it knows what the command M6453 is. It knows what to do when it sees it. If we hit compile, let's see if we still have enough memory on it. And yay, we had enough memory. Alright, so the last step obviously is to upload. You only want to do this once you have all of your configuration set for things like BL touch, auto bed leveling, however you want to do it, but let's just make sure that it actually successfully writes. I always find this funny, that now it's saying building in release mode, right, when it just turns around and writes the same firmware out. one of the key differences between Platform IO and Visual Micro, and the reason I prefer Visual Micro, is Visual Micro has in-system debugging. So if you compile a debug version of your program, it inserts code into there and uses the serial command to give you breakpoints and proper program flow analysis and 100 other things that are really, really nice to have when it comes to debugging a complicated program that you're not sure what's going on. Platform IO has none of that. They don't even really have a good layout of what files are contained in this project. Like, sure, you can see them all here, but I like Visual Studio's breakout where all the headers are grouped, all the CPPs are grouped together, and there's much clearer evidence as to where everything comes from. All right, so it says that it succeeded after it uploaded, and it claimed that it recompiled now a release version, and it didn't. It just took the same ELF that it had before, turned it into a hex, and uploaded it. Turned it into a hex, turned that into a bin, and then uploaded it to the board, and then downloaded from the board and verified that everything was the way that it was. Now, one of the things always you want to do is go ahead and clear out the EEPROM when you start, but that's a whole other thing. If we switch over to the terminal, and as you saw before, we'll enter M6453, and you see the light going, and you see the light go off. And that's all there is to it. So that is the basis of how to extend Marlin with custom Gcode commands. Questions, comments, down below. If you like this video, hit the like button. If you really like this video, subscribe. Stay safe out there. Thank you for joining me in the lab. I hope you learned something today, and we will speak again soon.